In this section, we'll have a look at location. Location describes where things are. In the previous section, we learned that spatial was special, and one of the reasons spatial is special is because we're dealing with data which has location. Whether that's you located in a city, or whether you're in the desert, or maybe you're at sea, or whether you're interested in phenomena like a particular forest or a coral reef, we really need to know where things are, or in other words, what is their location. So the question, where on earth am I, or where on earth is a particular forest type or coral reef, is very important in terms of geospatial information systems. In terms of location, we tend to think of location in two terms. One is in terms of absolute location, and the other one is in terms of a relative location. While we're thinking about location, keep in the back of your mind that we're going to be using this location stored in a computer and manipulated, perhaps with a programming language such as Python or something similar. So in our discussion of location, we're interested in how we might be able to store that location in a computer. Where things are, whether that thing is you or whether it's a particular feature you're interested in studying. So let's start, for instance, by asking the question, where are you? So I'm interested in where you are right now. If I ask you that question, what would be your answer? If I ask you the question, where are you? What would you say? I think the best way to do that is to actually write your answer down right now. Write down on a piece of paper where you are. I think most people would say something like, I am at home, or I am at work, or I am on lower campus, or I am at the shops, or I'm at the cinema. I can't imagine many people would say something like, I am at 17.5 degrees south, 178.7 degrees east. So you can see here we have two ways at least of describing where we are. What we'll look at now is the different ways in which we can describe location, and that may give us some insight in how we can store that location in a computer. Okay, in the previous slide I described a location in terms of a latitude and a longitude. If we use this type of method for describing our location, it's what we call an absolute location. So you can see here, here's the question, you are located at, and we have a particular latitude and longitude. So when we're using absolute location, we describe our position or location in terms of coordinates. Many of you, for instance, are familiar with the global positioning system. It's quite possible our coordinates in terms of latitude and longitude might come from a GPS satellite, download it to our computer. We can then use that for some kind of analysis operation, whichever we like to do, using our geospatial information system. So the important thing here is absolute coordinates, absolute location, are given using numbers, whether it's a latitude or a longitude, or whether it's a grid coordinate. We can describe our location in terms of numbers. This then immediately tells us, aha, computers are very good at storing and manipulating numbers, so perhaps absolute location is a good way to represent our location in our computer. But let's look at some of the other ways we can describe location. Let's have a look at relative location. You'll recall from the notes I made a reference to where am I? I'm at Uncle Johnny's place. Okay, so let's have a look at that in terms of relative location. Let's say Uncle Johnny lives here. I tell you I'm at Uncle Johnny's place. If you know where Uncle Johnny's place is, then you'll be able to find me. We'll find out later in your degree that taking a location in terms of a textual description, for instance, Uncle Johnny's place or Sakuna Park, if we convert that into an absolute location using text information, we call that geoparsing. And we'll look at geoparsing in subsequent courses at 300 level. For now though, if you don't know where Uncle Johnny's place is, we have a problem. So perhaps I could say, let's use a reference point like the Lammy post office, and I could say Uncle Johnny's place is 1100 meters north of Lammy post office. Okay, now I've given you a relative location because we have some kind of distance and some kind of direction. So together with these two, distance and direction, you can determine my location at Uncle Johnny's place. You know that in cities and towns we have what we call an address. That could be, for instance, 221 Queen Elizabeth Drive. Taking that address and putting that into absolute location is another term we use in geospatial information systems called geocoding. So, to summarize that, just specifying my address as Uncle Johnny's doesn't really give an explicit location unless we know exactly where that is, in which case we can geoparse that information into our coordinates. Let's say it's a latitude and a longitude. Or we have an address, our GIS system then can convert that to an absolute location using a process of geocoding. These are just some examples of how we have a relative location, but as we saw from the previous slide, in geospatial information systems, the best way to store our location is in absolute terms. Okay, let's just quickly recap on location. We've said location tells us where something or someone is. So locations are a very important property of our geospatial data. We also saw we could look at location in terms of absolute or relative location. We talk about absolute location, we're really talking about coordinate pairs, and we found out or discovered that having coordinate pairs is very amenable for entry into a computer and future manipulation. Those coordinate pairs could be either geographic coordinates in terms of latitude and longitude, where latitude is an angle measured with respect to the centre of the Earth, north or south of the equator, and longitude is measured east or west of the prime meridian, which passes through Greenwich in the United Kingdom. So these are angles, or we can run a projection, reproject the spherical Earth onto a flat sheet, and then apply a grid to that flat sheet and end up with an easting and a northing. Relative location is a bit simpler. We simply have some kind of distance and direction with respect to another point. So this would be our distance d, and if we're using a compass, for instance, this might be our angle. Okay, let's have a look now and see how we might take a relative location, convert it to an absolute location, which we can then put into our computer. Let's say this is the land, that's the sea, and we're at sea in our boat. Our outboard motor is broken down and we're stuck, and we want to radio our friends to come and pick us up. However, we don't have a GPS on board, but we do have some navigation instruments like a compass, etc., and we can determine from that with respect to the point, we are 1200 meters northeast of the point. How can we convert that example of a relative location into an absolute location? Well, let's set up a simple coordinate system here. We can see that we have an angle here. We know because we're northeast of the point that angle, theta, equals 45 degrees, being northeast. We also know our distance is 1200 meters. So now we have a distance and bearing, so we have a relative location. How can we convert that to an absolute location? Let's simplify that diagram on the XY. Here's the point. Here's our location in the boat. D equals 1200 meters. We know that theta equals 45 degrees. So we can set up a transformation this is delta y, this is delta x. And there's d. Okay, if we look at theta, we look here, we have delta x, which is opposite the angle, over d, which is the hypotenuse of this right angled triangle. So we can go delta x over d equals sine theta, and similarly we can go delta y over d equals cosine theta. In this example, sine 45 and cosine 45 are the same value, so sine 45 equals cosine 45, which equals 0.707 approximately. So we can see from these two formulas, delta x equals d sine 45, delta y equals d cosine 45. If you do the maths, delta x then comes out to approximately 850 meters, and similarly delta y also 850 meters. So delta x and delta y. What we need now is the absolute location of the point. So on the next page, let's say our point is at coordinate 2 million meters east, 4 million meters north. We know delta x equals 850 meters, and we know that delta y equals 850 meters. Therefore, our location equals 2,850 meters north, 4,850 meters. Oops. Sorry, that should be east, and this should be north. So now we have a coordinate. We can send that to our friends who can put it into their GPS and find us and rescue us. So there's an example of where we've gone from a relative location using a bit of simple trigonometry. We've converted that into an absolute location. So again, look, because our absolute location in this case is in grid coordinates, it's a number, and we can put this into a computer. In fact, a GPS is driven by a computer, and that is how we can then find ourselves and get rescued.